Okay, today we're going to be looking at experimental probability. Few vocabulary words and definitions. Chance process, first of all, and it's just that repeated observation of random outcomes of a given event. What we're looking at specifically today is our experimental probability. And that's the ratio of the number of times an outcome actually occurs to the total amount of trials you performed. So basically, again, it's the same as what we've been doing, creating those ratios. How many times I actually get the event that I'm looking for over the total number of trials. And of course, always simplifying them. So we're going to do a little bit of an experiment here. And again, the experimental probability means you're actually doing it. Theoretical was if all things in life were fair. So if I said, what's the chance that I flip a coin and get a heads? You would tell me 1 out of 2 or 50% or 1/2. But does that mean that if I go ahead and flip that coin 6 times, I am guaranteed to get 3 heads and 3 tails? Absolutely not. That is what we call that not experimental probability, but our theoretical probability. Experimental means I'm going to really flip that coin 6 times and see what happens. So let's see if we flip this coin and let's flip it, let's say 16 times. What would we get? Okay, let's keep a record. Let's flip this coin 16 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. All right, 16 times. Now let's record those results in our table. Okay, we've recorded those in our table. And our results, of course, we got 7 heads and we got 9 tails. That definitely isn't that 1/2, 50% from our theoretical probability that we've done previously. Now, there were some times where at the very end I got those last 2 heads where it was on a roll of just getting tails. That is the difference with experimental probability compared to theoretical. So if I said, let's go ahead and find that experimental probability of getting that heads, well, again, experimental probability is that ratio. How many heads did I receive? 7. Out of how many total trials did we do? How many times did we flip that coin? 16. Can I reduce it? I cannot. So my answer would stay 7/16. Now I could leave that 7/16 as a fraction because remember, probability can be a fraction, it can be a decimal, or it can be a percent. So if I wanted to, I could go ahead and change that to a decimal, or I could go ahead and change that to a percent. Do you have to? No. Either way, any of those would show me that probability. And that probability of a heads is less than that 50% that we were thinking of with our theoretical probability. Let's go ahead and look at that experimental probability of a tails. Well, I got 9 tails out of, I flipped it 16 times. Can I reduce it? No, there's nothing that can go into both. So again, 9/16 would be that probability. Or again, if you wanted to make it into a decimal, 0.5625. Or if you wanted to change it into a percent, that 56.25%. Either way, you can see, whoops, that actually gave me something higher than my 50% theoretical. The thing is with the theoretical and the experimental, that's because we only did this 16 times. If I flip that coin 100 times, 1,000 times, 10,000 times, you would actually find your experimental probability and your theoretical probability would actually start to converge to come up with that 50% that we were talking about. So if I only flip it a few times, I could definitely get some skewed results. The more I do it, the more it actually comes down to being almost exactly like that theoretical probability. So that's kind of the difference. And we're going to be doing a little experiment today in class. So bring any questions you have and we'll be talking soon.